So hello guys, in today's video we are going to talk about the covariance. So suppose, just a second. So in this video we are going to talk about the covariance. So basically why we use a covariance, let me solve this question first. So basically in a machine learning we are trying to solve a particular problem, right? In order to solve that particular problem we need to identify the relationship between two variables. Relationship between two variables so between two random variables I can say that. So in order to identify the relationship, so basically direction of the relationship, in order to identify the direction of the relationship we use covariance. So suppose we have a variable x and variable y. These both are random variables, continuous random variables, right? And I want to check the increase with the increasing of x, does y increase or decrease? I want to check that. So we can easily check that with the help of covariance formula. So this covariance formula is like this. Okay, so here I'm going to write the two random variables that I wanted to check the relationship direction of the relationship, right? So here I'm going to write 1 divided by n is equal to 0 to n. Here I'm going to write xi minus mu of x to yi minus mu of y. So this is the formula of covariance of x and y. So if this value will be positive, that means the relationship between two variables is positive, right? So means with the increasing of x, y is also increasing. And there is another perspective of this, is called with the decreasing of the x, y will also decrease. So this is if this is the case, if the value of covariance of x and y is positive, right? Now we are going to check the another case, which is case number 2. Suppose we have a value which is negative. After calculating the formula, we are getting the negative value. That means with the increasing of x, y is decreased, and with the decreasing of x, y is increased. So this is the second case. Now I want to check the covariance of x with x. What does that mean, right? So in the x of x, I want to formulate like this. My formula will changes like this: 0 to n, these are the same things, where xi minus x, sorry, mu x here, and xi minus mu x here. So this is the same as covariance of x with respect to x is the same as variance of x, because in the variance we have a same formula which will be like this: 1 upon n summation of I is equal to 0 to n xi minus mu x whole square. As you can see here, the both formula is the same. And if you forgot why we use what is the use of variance, so let me give you a short introduction about the variance. So generally, if we want to check that our data is well separated or not well separated or not, at that time we can use variance, right? And if you haven't checked the EDA section where I discuss about the variance, then you can get a link from the description, and also I uploaded video in my I button, right? So now it's time to cover the second topic, which is the Pearson correlation coefficient. Correlation coefficient. So with the help of this technique, we can easily identify the number or strength, we can say that the strength of relationship between two variables, between two continuous random variables, right? continuous random variable, right? Okay, so in the covariance that we have discussed that how we can identify the direction of the relationship between two continuous random variable, but here we can get the number that how this relationship is strengthened. Suppose here we have a x variable and we have y. So with the increasing of x, y is also increasing. But what is the strength of this particular relationship? Like 94% out of 100, like 50% out of 100, or 60% out of 100. What is the strength of this relationship? I want to calculate that. So with the help of Pearson correlation coefficient, you can easily calculate that. So what is the formula for this one? So for the, if I want to identify the relationship between two variables, then the equation for that is one like this: covariance of xy divided by sigma x or sigma y, right? So this is the equation for the Pearson correlation coefficient. So in this video we have learned how we can identify the direction of the relationship with the help of covariance, whereas in the second topic we cover what is the how we can identify the strength of the relationship with the help of Pearson correlation coefficient. So this is all about now, all about for today. Thank you for watching.